So hello friends, welcome to this video. In this video, we are going to talk about problem humming distance. So the problem states that the humming distance between two integers is the number of positions at which the corresponding bits are different. Let's copy this example and understand it. So you have an input something like x is equal to 1 and y is equal to 4. So if we represent these numbers into binary, it will look something like. So we need to return number of different bits in both of the binary representation. For example, if we talk about this position, there is 1 and 0. So the bit is different, so we add 1. If we talk about this position, both of the bits are similar, so we are not going to do anything. If we talk about this position, the bit is different. So in total, two bits are different and we have to return this 2. Let us understand how we can solve this problem. So I assume that you know the AND operation and the OR operation in binary. Let us learn about the XOR operation. What it does is, for example, if we have an input bit A and B, and this will be the output. So if we have input bits such as 1 and 1, the output will be 0. Why? Because if both of the input bits are similar, we give output as 0, and if both of the inputs are different, we give output as 1. No matter what the bits are, 1 or 0, we give. If the bits are similar, we give it 0. If the bits are different, we give 1. So this is XOR operation. How XOR operation is going to help us in this problem is, can look closely at this input. We will get the number of different bits in this binary representation. And how we can get it? It's using XOR. So we'll perform a XOR operation between 1. So how we can perform XOR operation? It's using the up arrow key. After performing the XOR operation, we'll get the output something as, if we look at this position, the bits are different, we'll get 1, we'll get 0, we'll get 1, we'll get 0. So this is the output which we are getting. And if we iterate over this output, and as we can see, there are 2 1s, so we return 2. So how we are going to iterate over this is using the right shift operator, which looks something like this. So this is the right shift operator, and how this works is, after we perform the XOR operation between these two numbers, we are going to perform AND operation with 1. So if I perform an AND operation with this number and 1, we'll get the output as this is 1 and 1, we'll get 1. We're not going to get anything, we're just focused on this particular column. If the last bit is 1, we are going to get 1. So after performing the AND operation, if we get a 1, we're going to add 1. If we get a 0, we are going to do nothing. So after I perform the AND operation first time, I get the output as 1 because the last digit is currently 1. Then what I'm going to do, I'm going to right shift this bits. What is the meaning of right shift? If we have 0 1 0 1, I'm going to right shift it and it will be converted to 0 0 1 0. This bit gets removed and this bit gets shifted towards the right, and so on. So we get output something like this, and we are going to again perform a AND operation with 1 and this number, and as the large digit is 0, we are going to get 0. So we're going to add nothing. Then again we are going to right shift, and after performing the right shift, we'll get the output something like this. 1 will get shifted towards this position. We'll perform in the AND operation, we'll get the output as 1. So we'll add 1. So this is the way how you can solve this problem. So let us see how we can code this. I'm going to remove this code. First of all, we have these two numbers. What we need to do, we need to perform the XOR operation between these two numbers. So I'll name it as XOR is equal to x. With the help of this operator, we can perform the XOR operation. After performing the operation on x and y, what we are going to do, we are going to declare a variable diff is equal to 0 currently, and then while XOR is greater than 0, so it will be and 1, and I'll store this in a temp variable. Okay, so the output of this line will be either 0 or 1. So after we get either 0 or 1, what we are going to do, we are going to add difference plus equals t. So in short, what we can do is cut this line and paste it here. And after that, what we are going to do, XOR is equal to XOR right shift 1. So we are shifting 1 time. After the loop ends, we are going to return diff. And if I run this code, I get an error because I think I should not use this variable. Let's run this again. Yeah, so we get the output. Let us do a quick dry run of this code. First input is x is equal to 1 and y is equal to 4. After performing the XOR operation, this variable will be having 5. Represented in binary is 0 1 0 1. And after the difference will be as it is. Then as XOR is greater than, this will be true. Then difference XOR and 1. So what will be the output for this? It will be 1. XOR is currently this. So at the last, it is 1. So it will be 1. Then after right shifting, what will be the output? 0 0 1 0. So this 1 will be gone and this rest of the bits will be shifted towards the right. And again, we are going to check if XOR is greater than 0. Yes, it is greater than 0, then true. And what will be the output of this? As XOR is this, last digit is 0, the output will be 0. So we are going to add nothing in the diff. Then we are again going to right shift XOR After right shifting, the output will be 0, 1. And now we will check if yeah, it's true. And diff plus equals, now what will be the output of this? It will be 1, because ending of XOR is 1. And after that, we are again gonna right shift. So after right shifting, this 1 will get removed. So x is not greater than 0, x became 0 now. As a result, this loop will end and we are gonna return different. So let us submit this code. So yeah, after submitting the code, we get the output. Thank you so much for watching this video. Have a wonderful day. Bye bye.